equation when there's a variable on each side of the equal sign. First, let's just practice a couple of those collecting like terms problems or distributive problems that we've already experienced so far. So let's grab a marker. Looking at this first problem, I'm just going to circle the like terms. We've got negative 6x and negative 2x. When we combine those together, we get negative 8x. And I also notice I've got a 3y and a minus 9y. When I combine those two together, I get negative 6y. And then lastly, there's a negative 9 that's all by itself, and it just becomes part of the final answer there. So there's a simplified equation, or an expression, excuse me. This next one, we actually have a distributive property question here. So we need to do negative 7 times 7, multiply that. We get negative 49. And we have negative 7 times 6x, which makes that negative 42x. And that equals 203. Then we add 49 to both sides. So we add 49 to both sides. Add 49 on this side as well. And give ourselves a little more space. This cancels, and I'm left with negative 42x equals 249, 252. And we divide both sides by negative 42. We end up with 6. So x, well actually negative 6. X equals negative 6 is our answer. So that's how we handle solving an equation that has a distributive property part of it that needs to be taken care of. Okay, so in the past we've talked about the Great Wall of China and how sometimes in the past the people on one side of the wall over here thought that whatever was on the other side of the wall was a great mystery, all right? And what we're trying to tell you is that it's not a great mystery, not a great big question mark, as I'm trying to illustrate there. We can actually find out what's on the other side of our equation by using a little bit of simple algebra. So let's see what we're talking about. So we're solving the equation with variables on both sides. What you end up doing is you collect the like terms on one side of the equation, or one side of the equal sign or the other. So what I want to do is I want to collect all the x's on the left side and all the constants on the right side. So let's start out by rewriting it. So we've got 2x. When I move this across the equal sign to collect it with 2x, it has to become its opposite. So it becomes minus 5x. I still have 9 over here on this side. And this 3 right here, it wants to move over and join up with 9, but since it's positive 3 here, it becomes minus 3 over here. It's like subtracting 3 from both sides of the equation. And when I do that, I'm left with now negative 3x equals 6. Divide both sides by negative 3, and I end up with x equals negative 2. So there's a quick look at the general process of what's going on here. So let's try a few examples and see how we do. So first thing you're going to do is use inverse operations to get the variables on one side, and then add or subtract to both sides to find the equation. And then we're going to multiply or divide to both sides of the equation to finish that last step. So it's basically we're turning the equation back into a 1 or 2 step equation by doing this and then finishing it off. So here's another problem. So we'll move all the variables to the left side. So I have 5y and 2y, and so I'm going to collect them over here on this side of the Great Wall of China, or the equal sign. So when I do that, I end up with 5y and a positive 2y when you bring it over, or in order to remove it off of this side, you have to subtract 2y from both sides. Then I'm left with, on the other side of the equal sign, negative 2 And this negative 14 over here becomes positive 14 on the other side. It's like adding 14 to both sides to get it to move. So now I'm just left with 3y equals 12. Well, let's divide both sides by our friendly little 3, and we end up with y equals 4. No, I don't think this is looking all that hard, and all I'm doing is adding or subtracting, multiplying or dividing integers once again. Okay, here's a nice little problem. So let's move all the variables to the left side in this case. So 6n is already there. We've got our equal sign, and then this end is going to move across. Since it's positive here, it becomes subtract 1n on this side. We still have 3 on the right side, and negative 12 is going to jump to the other side to collect with the 3. So we're collecting the like terms. 6n minus n is 5n, and 3 plus 12 is 15. Let's clean up that n a little bit there. Now we're going to divide both sides by 5. And when we do that, we get a nice answer. N equals 3. This is looking pretty easy to me. I hope you're starting to see that too. All right. And this says bell work, but this is actually one of our examples. So I want to move all the variables to the left side on this problem. So I've got negative 4m already there. Cross that off, bring this 2m over, and it becomes minus 2m equals 32, and bring the 8 across, and it will become minus 8. It's like we're subtracting 8 from both sides in order to move it and cancel it off of that side. So 32 minus 8 would be, you guessed it, 24. And negative 4m minus 2m is negative 6m. So if I divide both sides by negative 6, move it down so we can have a little more space here, we end up with m equals negative 4. All right, we got, how many more we got? We got one more example. We can do this. Now we've been doing it kind of simple, moving everything to the left side, but you know, there's more possibilities here that we'll show you as time goes on. But we have negative 4 on the left side already, and we want to collect all of the like terms or the a's on the left side. So this positive a becomes minus a. There's our equal sign. 32 on the right side calls over to 7, says, hey, come collect with me. So the plus 7 moves across the equal sign, it becomes minus 7. And negative 4a minus 1a combines together to give us negative 5a. And then when we do 32 minus 7, we end up with 25. So we divide both sides by negative 5. And then that results in a final answer of a equals negative 5. So this is just an early look, introductory look at using or solving equations that have variables on both sides of them. So take a look at that and do the ALEKS assignment to see how it works for you.